Hi, Tanvi. So for this example, what do we need to do? We need to first try and draw the diagram as given. So first of all, let me just draw this, a metal bar. So this is my metal bar. Let me just call it AB. Okay. So this is A and that's B. It says it is 70 centimeter long. So can I say that its weight lies at O, which is, oops, 4 kg, sorry, 4 kg F here. That is the weight because 4 kg is mass. Then it is 70 centimeter long. So can I say given weight W is 4 into 9.8, whatever it comes, we will just write it down in Newton here. Now it says its center of mass se hota hai. I can say AO is 35 centimeter and my OB is also 35 centimeter. Now the question comes that, that is in kgf and that one is Newton and this one is centimeter. As we know, the things cancel out. Once we match, it cancels out. So it's okay if I'm writing that in centimeter. Now it says that it is supported by the two knife edges placed at 10 centimeter from each edge. So if I can just call it, the knife edges are P and Q, and there are some reaction forces on it, because if it is holding it, there is a reaction force on it. So I'm calling it R1 and R2, and I'm calling it P and Q. Very weird Q. So I call AP is 10 centimeter. AP, why I'm writing B? It's AP 10 centimeter and QB is also 10 centimeter. Is that right? Till now, that is the case. Now it says a 6 kg weight is suspended at 30 centimeter from one end. So if I'm just assuming from A 20 centimeter here, let me just say a weight W dash is acting. Let me just mark it W here so that we don't confuse. W is the weight of the rod. W dash is the external weight that I'm putting. Let me just call it W dash is equal to 6 into 9.8 Newton. Let me just calculate both the values and write it down here. It is 9.8 into 4, which is 39.2 Newton, and it is 9.8 into 6, which is 58.8 Newton. Okay, so this is what is given, and it is asking find the reactions at the knife edges. So what is being asked? R1 is question mark and R2 is question mark. That's what. So we have interpreted the question. We have taken out what we need to. We have mentioned it what we need to calculate. So here, let us start by taking, as my rod is in equilibrium. And when my rod is in equilibrium, I'm talking about the two types of equilibrium. One is the translational, other one is the rotational. My bar is not going up, my bar is not coming down. So I call it translational equilibrium. In that, whatever upward forces are there, they are equal to the downward forces. So what are the upward forces? Here, it is R1 and R2. What are the downward forces? It is W dash plus W. So do I know the value for W dash and W? Yes. So I can say R1 plus R2 is equal to 58.8 plus 39.2. That is 98 Newton. Clear? This one thing is there. Now, second thing, my bar is not rotating, neither here or there. So I'm calling that my bar is in rotational equilibrium too. So I just write it down, rotational equilibrium. And I just say, now rotational equilibrium, you need to think. If I am taking any point, आप कोई भी एक point लो और उसके around rotation देखो. Let me just take it around O. Okay. So OK around, if I'm talking about R1, where it is trying to rotate it. So as I could see, R1 is trying to rotate it in a clockwise direction. Which direction W dash is trying to rotate? In the anti-clockwise direction. Which direction R2 is trying to rotate? It is trying to rotate in again anti-clockwise direction. So can I say that in a rotational equilibrium, the clockwise moment is equal to anti-clockwise moment? Is it right? So what I write, rotational equilibrium, sum of anti-clockwise moment is equal to sum of clockwise moment. And for that, let me just see. Anti-clockwise कौन से हैं? W dash, oops, sorry for all these gestures. W dash and R2. So let us just see. What is the distance between W dash and W? I know AO is 35 and so sorry. And A, wherever this force is acting, I'm calling, let us say this is some point O dash. So OO dash, it was, I could see that it is 30 centimeters. So OO dash is 35 centimeter. 35 minus 30. So I call W dash into OO dash plus, what is the another thing? R2, which is trying to rotate it in the same direction. What is the distance between them? OQ distance kitna hai? I can see that if BQ distance is 10, OQ left is 25. So I can say R2 multiplied by OQ. It should be equal to sum of the clockwise moment, which is only one, which is R1 into PO dash. Sorry, R1 into PO, because O के around हम ये ले रहे हैं. So R1 into PO. Now let us put the values. Okay, so I get W dash, which is 58.8 multiplied by OO dash, which is 5 plus R2 into OQ, O into Q, it is 25 plus R1 into PO. PO is again 25. So I just take out 5 throughout. I get 5R1 minus 5R2 is equal to 58.8. So I can say R1 minus R2 is 58.8 divided by 5, which is 11.76. Now, if I just look at this as equation 1 and this as equation 2, I can see it just by looking at the equation that I need to add them. So I call adding equation 1 and 2. R1 added up, R2 cancel out. So I get twice of R1 is equal to 98 plus 11.76. So R1 comes out to be 98 plus 11.76 divided by 2. That is 54.88 Newton. And if I put this value in equation number 1, so I get R2 as 43.12 Newton. Okay. So that's how you solve this question.